So today we will discuss address resolution protocol, ARP. So that's part of the IP layer, network layer. So if you recollect, so you can see the slide as well as hear my voice, both. Yes, no. Someone please respond. Yeah. Hello. No.
Yes, sir.
Okay, right. So we'll discuss address resolution protocol, ARP. This requires us to go back, shuttle between the data link layer and remember that data link layer and the network layer. Remember, your IP protocol does not strictly define something called as a data link layer. Okay, it doesn't have something like that, strictly speaking. So if you say this case, it's called as a network interface. It's called as a network layer, something like the network interface, like that. Different namings are there, and this is actually your internet layer. It's what you can call as a network layer. Okay. So the lower layer is not having a lot of basically the TCP/IP model defines from this way on, from the internet layer, IP layer onwards. IP layer, it doesn't bother what is below, it just bothers about this IP. IP is a protocol that can span over diverse things. That's what. And we are going to discuss this address resolution protocol, ARP. So this is the strategy. So we have discussed this addressing, routing. We discussed quite a lot of three routing algorithms as well as routing protocols. Then we went to this what do you say, we are now in address resolution protocol, IP support protocols. Now then after that we need to take up TCP, then UDP, that both of them come in the transport layer. Then we go to application layer where we get much more better idea of the things, how the things work at the top layer. That's what having the interface with us. A human interface layer is the application layer. We are not we are using a browser, whatever, WhatsApp, all this application layer software to interface. Most people use that, except what is it? You say nerds, you use terminals, all those things. Other people they work at the most people, 99% of the people use some interface which is convenient to them. Okay, so these are the four things. RARP is somewhat obsolete. This reverse address resolution protocol is somewhat obsolete. So we'll discuss ARP, then we'll go to DHCP and ICMP, and then come to ARP. Because once DHCP is there, this reverse address resolution protocol is become obsolete. It's just for academic interest, it's included there. Some reason they forgot to eliminate it from the textbook, right? So we'll discuss that after DHCP. DHCP is very we are experiencing every now and then. Every now and then you connect your ISP. You are allocated, unless you have a static IP, you are always a dynamically allocated IP. And then we will see. We will try to capture DHCP messages, packets using what is the tool? Yeah, Wireshark. Right, Wireshark. We'll use Wireshark to capture and see in real time the DHCP messages, all those things. ICMP, we saw ping. Ping uses ICMP messages. Ping www.google.com. You will see the command which is showing ICMP 0, 1, 2 message sequences, right? So it's a message protocol, internet control message protocol, right? So you are aware of this TCP/IP layer stack, and we are now in the network layer, and we will occasionally jump to this and come back. Okay, so address resolution protocol. Now we are aware of a couple of addresses in the internet protocol suite. One is your physical address. Physical address is defined at the MAC layer. I mean the data link layer, right? It's in the data link layer. You call it as a MAC address or the physical address. We discussed this thing earlier. It's a what do you say? You have octets, right? so you have a physical address. You say, if you run the command ifconfig/all or ipconfig, you can get the physical address as well. This is represented in the hexadecimal format. There are other addresses, 64-bit addresses, but most use 48-bit addresses. So that is a standard specified by your IEEE. There is a unique address for the manufacturer, and then this is your address of the device. So unique prefix is there. You can spoof this MAC address, you can clone MAC addresses, you can change your MAC address, right? There are different ways to that. So always associated with your network card, and you are connected to the net means your your hardware address is known, unless you have some mechanism to dissuade showing that IP address. There are n ways. If there are n ways to block this, there are n ways to bypass this also. Okay, so these are moving in synchronization, all those things. So this is called as a physical address, or you call it as a link address, MAC address. So it's the data link layer, the physical layer, this layer, this level, it operates at this level, right? And we discussed this when we discussed Ethernet. We discussed it when we discussed data link layer also. Both cases we discussed that. At this lower level, you have bits, zeros and ones, and all the media, right? Now the IP address is at the network level. It's at the network level. It has two variants as of now. There is a 32-bit IP address, IPv4 addresses, and 128-bit IPv6 addresses. So these two are there. These two addresses are there. Okay, right. So we haven't yet discussed IPv6. I expected someone to take up a small seminar on 10 slides on this. If that doesn't happen, I'll myself take it. Okay, so we'll have it in the end. Probably we'll just go in flow with the IPv4. It applies, most of the concepts apply there. So then this is for routing between networks. So this is a global address. So you are now the question is, how will you know the address of this? Say you are typing in www.google.com, or you type in ping google.com. How is that IP address known to us, that server, or www.cet.ac.in? Say we saw the thing that is that there we have something called as we have DNS, domain name system, and all those things are there. So that comes later. But as of now, IP address is there. And then socket address is a combination of this IP address and the port. So each of these communicates to a higher level using the port address. Port address is used to communicate your process to the higher layer. So the port address and the port number, with a specific port, it is communicating to the application layer process. Some process is running on the application layer. Say for instance, the WhatsApp client is running on the application layer, and it communicates via this port number 69. So the port address plus the IP address of destination network, that we can call it as a socket address. Then this is what we are more familiar with, DNS, domain names. So there is a translation working beneath. When you type in youtube.com, there is a process which is going behind the scenes of converting this youtube.com to some numbers. Say we are aware of such a thing, right? We are aware of how this happens. If you type in, I am not sharing the screen. If you type in www ping.youtube.com, it's converted to an IP, right? That IP is 172.168.26.206. That is that conversion. There is a mechanism for this, which we will discuss later, which we will discuss in the subsequent sessions when we take up DNS application layer, right? So as of now, our discussion is about this physical address, ARP. Address resolution protocol is some mechanism, is a protocol which is used to find out your physical address. If you have your IP address, you have an IP address. How will you find out how can you find out the IP address to the physical address, the MAC address? How can you find it out? That is what is is done using this address resolution protocol. Address resolution protocol does this task. So for each link you need each link you need to examine, you need to find out the link on the MAC address of the destination. We'll explain this concept. So this is operating within the boundaries of the network, but if you examine the case here, so this is it is accepting an IP address and it maps it to a link address and then passes this thing to the data link layer. It is part of your network layer. It is part of your network layer. ARP is part of your network layer. Remember that thing. ARP is part of the network layer. It is not part of the data link layer. Rather, it is part of the network layer. So, address resolution protocol is a protocol which runs within the network layer. So, it takes an address in the IP protocol and maps it to the corresponding MAC address and passes this value to the this thing. So, the how it does is will become clear when you examine. When we have done, we have visited this thing some time back when we discussed the data link layer. If you remember, your physical address and IP address, they are denoted by physical address, or link address is denoted by L, and network address or IP address is denoted by N. Now here I am sending a message from Alice to Bob. These are two characters, just like so Alice and Bob. So the Alice has an IP address N1. Alice has an IP address N1. Alice has an IP address N1 and Bob has an IP address N8. Alice somehow knows the IP address of Bob. How it is, that's a discussion for later sessions, but it knows. So it makes a data frame, and it's in the data link layer now. It's in the data link layer frame. So data is coming from your network layer. So this is your network layer, and network layer you have, and it passed on to the data link. It's passed on to your data link where it is framing. One of the tasks of data link layer is framing. Data link layer is framing. So framing happens here. So frames are made, and it has the source address, that is N1, and destination address, and the datagram that comes from the IP datagram that comes from this network layer, it is broken down into several frames depending upon something which we call the allowable size. If it is a big message, it is broken down, and the frame is broken down, it is sent to the next immediate router. This is, you call it as this R1 as a source router. It is also part of this interface. Now how Alice will know this link, that is a question. Alice will know this link, that is already known, but we need to know. So it is hopping over each of these links, each of these intermediate links. So if you notice here, the link address is L2, then again each of these have each of these point, if you observe, the link address will change, whereas the destination address N8 doesn't change. The source address doesn't change. It is still N1 and N8. The link addresses do change at each hop. Now link addresses are to be known. Link addresses change from one node to the next. Finally, IP address or your network address is the global thing. Now your address resolution protocol is allowing this mapping. How you can change this link address from one hop to the next. That's address resolution protocol, the use of address resolution protocol. Okay, address resolution protocol is used to do this task. How it does this task, that is our next discussion. Any doubts on this? Right. So basically, if you take the case, this is your any system, say it wants to send this data. If you take, first we will take the example of a single network. So here A wants to send some data to system B, and it doesn't know the link address of A. It knows the IP address N2. A knows the IP address. A knows the IP address of A knows the IP address of system B, N2, but it doesn't know that this is the link address is this. So it sends out a broadcast. It sends out a broadcast, ARP request. ARP request is broadcast over the entire network, telling that I am looking for the physical address, the MAC address of a system with the IP address N2. IP address N2. So, and that is broadcast, and all the systems will receive it. So it is received at the physical layer, then it is passed on to the data layer, and it goes into the network layer, where the network layer, the address resolution protocol of each of these systems, say L1, L3, L4, means this, I'll say this is C, D, okay, C, D, B, all of these systems, network layer will receive this thing, and the ARP address resolution protocol in the network layer of each of these will examine this packet. At each level it is decapsulated, the packet is decapsulated, and the message is examined, the broadcast message is examined. Checks the IP, the network layer, only the network layer knows is concerned with the IP. So network layer understands that, the C understands that this is not my IP, N2 is not my IP is N4. D understands that my IP is N3, it's not N2, so it will also discard this. Only this message, only the system B will respond. So this is a unicast message, whereas this is a multicast message, it's a broadcast message. Okay, so ARP, it replies only to this particular system A, telling that, say, I am the node with the IP address N2, and my link address, my physical address is L2, right? So that's it. That's ARP. That's ARP. So this is the way. It is like asking. I come to the class and ask who is coming from this village, from Ladakh, right? And two people are there, stands in response, say I come from that village from Ladakh, right? Same way, rest of the people, so Ladakh, two people are there in our class, so I just gave an example. Okay, it can be any place, Thrissur as well, no problem. So since we had a discussion about this before the class, I just mentioned the same. So it responds, only the person concerned responds, person with this link address responds, right? So this is what, it's a broadcast. So on the Ethernet it is all Fs, 255s. So that is this is what the sender MAC address. It will send its MAC address, that is L1 or L2. MAC address or L1, yeah, and its IP address, and the IP address of the receiver. I have just elaborated whatever was mentioned in the previous slides. Okay, right. So broadcast, reply is unicast, ARP request is broadcast. We will see an example. So this is a format of ARP, hardware type. So hardware type, it's all self-explanatory. So that is Ethernet, it's given the type 1, protocol type IPv, it's 0800. So then hardware length of the protocol length, that's all have to do with the IP layer. Then request is having the operation, the value field 1, reply is to, reply is unicast, request is broadcast. Source hardware address, in our case the A is link address, protocol address, source protocol address, IP address of A, that is, I'll say this is N1, and this case in the response, if it is a request, this is all zeros, right? And destination protocol address, you know the IP address of N2, IP address of B, that is N2, right? And it is sent. So this is the process. So this is explanation of how this thing works. So this is the ARP request message. This is protocol length 6 bytes, 4 hardware, all those things, hardware length and protocol length is there, and it is a request message, that is 001. It's a multicast frame, right? Multicast frame on destination, it's all M, all F. Data will be like this. So this is broadcast. Unicast frame, multicast frame, broadcast frames we saw in data link layer. If you just check the slides or the videos, you'll find that it's sent to everyone. And then what happens, the B will respond like this. It will say, this is my link address. So this is my link address. So this is the source now. B is replying to A alone. This is my hardware address, this is my IP address. A already knows the IP address of B. Some way it knows. That is, the router has a forwarding table. That can be a way. Router A can tell. That is one way to know that. Router knows the IP address assigned to this. Even your home router knows the hardware address assigned, the hardware address to the IP assigned to each device. Router settings 192.168.0.1. അതാണ് സാധാരണ ഡിഫോൾട്ട് ഡീലിങ്ക്, അതെല്ലാ മോഡത്തിലും അതൊക്കെ തന്നെയാണ്. എല്ലാ ഹോം റൂട്ടേഴ്സിലും അതാണ്. അതിൻ്റെ നിങ്ങൾ വൈഫൈയിലോ ഇന്റർനെറ്റിലോ കണക്ട് ചെയ്ത് നിങ്ങൾ ഹോം റൂട്ടറിൻ്റെ അഡ്മിൻ പേജിൽ കയറാം. യു സീ ദാറ്റ് കേട്ടോ. ആവശ്യമില്ലാത്ത സെറ്റിംഗ്സ് ഒന്നും മോഡിഫൈ ചെയ്യരുത്. ബട്ട് യു ക്യാൻ ഓൾവേസ് സീ, ആൻഡ് ഇഫ് യു മേക്ക് എനി ചേഞ്ചസ് ജസ്റ്റ് പ്രസ് ക്യാൻസൽ ആൻഡ് എസ്കേപ്പ്, or just pull out the power from the router if you are very afraid. But try out these things. It's always good to know all these things. എപ്പോഴെങ്കിലും ഒരാൾ പറഞ്ഞു നെറ്റ്വർക്ക് ചെയ്യാനുള്ള എഞ്ചിനീയർ വരൂ എന്ന് പറഞ്ഞാൽ എഞ്ചിനീയർ പോയി ശരിയാക്കി കൊടുക്കണം. ഞാൻ ഇലക്ട്രോണിക്സ് ആണ്, കമ്പ്യൂട്ടറിലെന്ന് പറയരുത് കേട്ടോ. You will be able to do that. It applies to everyone in the class. There is gender equality in this thing. Equal opportunity ആണ് എല്ലാവർക്കും. Now you don't you will cache this ARP. You won't, if every now and then for each packet you send an ARP request and then finding out this thing. This is not a very good process. Oro packet send cheyananga cheyunnu, it's not a good thing. You cache this ARP. You cache this ARP cache is maintained at each node, and then you will just some of the ARP entries are removed dynamically. Just like we saw in routing, there is a time to live alla expiry time under. The cache entries are removed after some time. This is how long you can set this in your Ubuntu system. You can use this thing. You can verify the stale time. The food became stale എന്നൊക്കെ പറയുന്നത് പോലെ എത്ര നേരം ARP cache is maintained. The entries in the ARP caches are maintained. That is can be adjusted also. You can adjust in this. If you go to this, we'll edit this value. You can adjust this thing. So, and again, this is from this post, the Stack Overflow thing. I got this idea. Anyway, it's not my finding. It's there. Big people are there in Stack Overflow. They are very volunteer service, but they give the people who answer questions on Stack Overflow like forums. They are one of the best people in their area, most of them. Some people just be there to clear doubts. Like me, we are there to clear our doubts. So, but it's always good to see people replying. You will get n solutions, most of them working solutions, right? Now this is one example which we time okay, we'll take 5 more minutes. Okay, 5 more minutes. We spend some time waiting for these people. Only for 34 people are there still in the class. ഇങ്ങനെയാണ് നിങ്ങളുടെ വഴക്ക് പറയുന്നത്. So I am feeling hungry. We'll wind up. Say Alice Bob in ഒരു കേസ് കൂടി എക്സാമിൻ ചെയ്തിട്ടുണ്ട്. We saw ARP now within a network. Now we will discuss about how across networks, just like this case, how you have intermediate routers and all those things. That will really clear give you the full picture of the things. So Alice has a source router, that means your ISP, you can say, and then Bob also has a source router, and this is a network. This you can put it as a cloud. This is a cloud. So there could be a lot of intermediate routers, all those things. That's your internet, right? Internet will be there. So all those routers are interconnected. All such things are there. So now this is the situation here. Alice is sending this to Bob. It knows some things. It knows its IP address, as well as some way it knows the Bob's IP address, right? So it will form this is the network layer of Alice. This is the Alice network layer. Whatever happens in Alice case, that has been said first. Now Alice is having what do you say, its IP address and the Bob's IP address, and it forms a datagram, IPv4 datagram, you can say like that, and passes it to the data link layer. Now the problem here is that the data link layer here Alice has to find out its link address. What is this link address? Okay, this link address avadeyana ARP work cheyyunnathu. ARP works here. So Alice is network is routing table here. We saw the routing table, alle netstat vechokka nammal kandarunnu, netstat ss ഒക്കെ വെച്ച് നമ്മൾ routing table ഉണ്ട്. We have a local routing table. It's to forward it to link n1. That's known, this IP routerന്റെ ഈ ലിങ്കിന്റെ ഇന്റർഫേസിന്റെ IP ഇതാണ് n1. So it is to be forwarded to this IP, but it doesn't know the link address. So how this link address can happen is that the router 1 ARP in the router 1 will respond. So Alice will send a message and then it will know. So and its own link address can be known from its own interface. അറിയാം, നമ്മളുടെ IP നമ്മളുടെ സിസ്റ്റത്തിന് തന്നെ അറിയാം. Alice knows its physical address as well as its what do you say, IP address and Bob's IP address. Now this is obtained by an ARP process, ARP request and ARP response. So it will say, I have my forwarding table says that to reach n1, to reach Bob, I should forward it to this IP. Now I am looking for, this is the process, I am telling in statements. Alice computer is telling that, Alice network layer is telling that, see, my forwarding table tells that I have to reach Bob's network, which has an IP address NB. I need to forward this packet to some network which has an IP address n1. Now just tell me what router, please tell me what is this IP address, what is the what do you say, link address, the data link address, the physical address corresponding to this IP address. That is the ARP request, and then in response there is an ARP response which is unicast, and then that is added to this, that is passed on by the network layer to the data link layer, and data link layer adds this thing here, data link layer adds L1 here, right, and then it is passed on to the physical layer and it goes as bits to this. We are reached only here, there is still a long way to go, right? So that's what clear here. So it's at Alice side. Now it's the next level. Next level, there is these two, R1 and L2. The same process happens. Say at the R1 router 1, the router 1, this router 1, this router operates at the three layers: physical, data link, and network. So this decapsulation process happens, and so link address is there. Decapsulation process happens, and then it says, the router 1 says that, say, I have to reach NB, and my source address is NA. I have a packet here, and my forwarding table says that to reach NB, I need to send it to our link N3. Now just router 2, so it will just say router 2, that is the router 2 which is having this IP address N3, the interface, telling that, say, tell me which is your link address. So there is an ARP process happening here, and it gets this link address, and it just passes on to its data link layer. It just adds it here, L3, and the source address is its link address, source link address is its link address, and destination is L3. It's passed to the physical layer, R2. Then the same process happens here. The final step, the same process happens here. The R1, so that is at router 2. So what happens here? It is R1 decapsulate all these things, and then it says, to reach NB, I need to send it to NB. Just tell me what is your link address. Bob, tell me your link address. So the ARP process happens, the link address is required. That means router, this is a source router for, you can say, destination router, or it's a source router for Bob. So Bob's router obviously will know if the ARP cache is maintained here, it knows. So Bob or Alice also, for once communication is established with Bob, that link address LB is maintained in its ARP cache. That's there for some amount of time. Then if when it times out, again request happens. So this summarizes. So you are flowing across the net, your packet is traversing across the net, your IP address remains constant throughout, and your link address changes at each hop. This is how this mechanism works. So this works very beautifully, and finally your packet is reached there, the ARP cache is updated here. Now they can communicate. Alice, Bob. Then there is a third character, Eve. ഈ ക്രിപ്റ്റോഗ്രഫി ഒക്കെ പഠിക്കുമ്പോൾ ഒരാളും കൂടി ഉണ്ട്, 3-4 ക്യാരക്ടേഴ്സ് ഉണ്ട്. നമ്മൾ ജനറിക് ആയിട്ട് പറയില്ലേ, പാത്തുമ്മ, അതുപോലെ ക്യാരക്ടേഴ്സ് ഒക്കെ ഉണ്ട് കുറച്ച്. So that's same way. So this the comedy shows, that's why I mentioned the character, right? So this is the Bob's computer. Finally this is the process. So it just gets this thing, it is happy. Right, now these two commands, you can try out these two commands. You have these same commands in Windows. You can try out these two commands. You have these both these commands in Windows as well. ARP-V, ARP-A. So that is, I'll just show the terminal. Where is the terminal? It's running, right? There is terminal na command run cheyidu nokku.